Now, the last part of this was if flux equals to 0, what can we say about the charge residing inside the tube? If flux is 0, no charge is there inside. That is one option. There may be like this. Second option, there are charges like this. Suppose there are 3 charges inside that. Plus 3q, minus 2q, minus q. So what is the net charge? 0. So either net charge is 0 or, no charge is residing inside that, or charges are there, but the total sum of algebraic sum of the charges is 0. Let us do a very easy sum. This one. Question number 18. A plus 10 microcoulomb charge is placed 5 centimeter above the center O of the square plate. You have to find what flux would be passing through this plate. That's it. Yeah, that's it. You need not to calculate it. Well, you tell me what may be the total flux coming out of it in all directions. Let us calculate that. Total flux is given by phi equals to q by epsilon naught. Now q is how much? 10 microcoulomb. That means 10 into 10 to the minus 6 divided by epsilon naught 8.85 10 to the power minus 12. Remember one thing I told you earlier, to remember the value of 1 by 8.85 into 10 to the power minus 12. Anyone remembers that? I told you. If I can write this thing to be 10 to the power minus 5, then into 1 by this thing used to be 11.3, I told you, 11.3 into 10 to the power minus, 10 to the power plus 10. I suggested you to remember this. Anyway, so it becomes easy. Ultimately it becomes 11.3, 10 to the power minus, plus 5. This is the total amount of flux that can come out of a charge of 10 microcoulomb. Now, through this plate, what would be the flux coming out of it or passing through this? Let us do one thing. Draw this 10 centimeter walls, big tall walls of 10 centimeter. From here also 10 centimeter wall, here also 10 centimeter wall. So if you join these walls, what do you get? You get a cube. You get a cube of each side 10 centimeter. Now, this charge, though doesn't appear to be, but this charge is inside or at the center of this cube. What can guarantee that it is at the center? This height guarantees it, this value guarantees it. Why? Because 5 centimeter is half of 10 centimeter height. So it is midway, the floor and the ceiling, here it is 5 centimeter. So it should have been over here to appear exactly at the middle. So all the flux coming out of it will hit all these 6 faces, and we did it earlier that through each face of a cube, flux would be how much? 11.3 10 to the power 5. There is the total flux by a big 6. Why? It will be distributed uniformly among all these 6 faces. So this should be the answer. So this may be something around to do this sum. One thing is very important, that you need to draw this perfectly with care. This cube. It is given that a charge is placed at the center of a cube of each side 9 centimeter. Look at the unit, 9 centimeter, CGS. So what should be the flux through this cube? So we know that flux coming out of it as a whole given by Q by epsilon naught equals to, let us put the value. Q is 2 microcoulomb, 2 10 to the power minus 6 divided by epsilon 8.85 10 to the power minus 12. See, again, I told you to remember this value. Its value is how much? I told you earlier, 11.3 10 to the power 10. Just remember this. It will help you calculating. Into 2 into 10 to the power minus 6. So equals to, just multiply these two things. So it will become 22.6 into 10 to the power 4. This much Newton per coulomb into meter square. Newton meter square per coulomb. So this is the flux. And it doesn't depend on the size and shape of this Gaussian surface. That also I told you in that part where we had discussions and limitations of Gauss's theorem. There was a topic. There I told you it doesn't depend on shape or size. That means if the cube was a bigger one, then also same flux used to pass through it. So this one is question number 20. Here it is asked that a charge Q is placed at the center of a sphere of radius 10 centimeter. And it shows that it involves a flux equal to this much, minus 1 into 10 over 3 Newton per meter square. Now they have asked that if the radius of this Gaussian surface were doubled, suppose a bigger Gaussian surface was there, what would have been this flux? So part A is flux will remain the same. As I told you earlier, it doesn't depend on the shape or size of the Gaussian surface chosen. Second part, B. They have asked how much charge is placed at the center so that this much of flux is generated. So easy. From Gauss's theorem, flux equals to Q by epsilon naught. That is, Q should be equals to flux into epsilon naught. Equals to, flux is this much. You can take negative sign also. If you take negative sign, it would be minus 1 into 10 to the power 3. Then also it will come negative. 8.85 10 to the power minus 12. So, this 10 to the power 3 and 10 to the power minus 12 will make 10 to the power minus 9 and 8.85. This much